let's continue where we left off before. We're on 7d 2/5 to the negative first power. So in this case, we have to apply a rule that we talked about earlier. The -1 goes to both the numerator and it goes to the denominator. So now we have 2 to the negative first over 5 to the negative first. And we don't want any negative exponents, so to get rid of those, you have to flip it over the fraction bar. And in class, we're going to talk about our wrap. And the next line to the wrap is negative exponents leave a scar, so you knock them over that fraction bar. So we take our 2 to the negative first, and we flip it over the fraction bar. When you flip it over the fraction bar, you're left with 2 to the first because the sign on the exponent changes. So if it was a -1, now it becomes a +1. We still have a 5 to the negative first in the denominator, and in the numerator we're left with the hidden 1. Quotation marks around hidden 1. So then from here we also need to move this value because it has a power of -1. So when we flip it over the fraction bar, the sign of the exponent changes from a -1 to a +1. And that's multiplied by the hidden 1. In the denominator, we are left with the 2 to the first. In the numerator, 1 times 5 to the first power is 5 to the first power. And we simplify this to 5/2, or 2.5. Let's look at E. Again, we have to use two rules here. We have to take the -3 and give it to both the numerator and the denominator. So we're left with 1 to the -3rd over 2 to the -3rd. Negative exponents leave a scar, so you knock them over that fraction bar. So the 1 to the -3rd goes in the denominator. We flip it over the fraction bar, and the sign of the exponent changes, so it becomes a +3. Now, up here would be a hidden 1, but I'm going to skip that step because I'm going to right away flip this over the fraction bar in the same move so that I can do this faster. When you flip something over the fraction bar, you flip the entire thing, the base and the exponent. And the sign of the exponent changes to a positive in this case because it was originally negative. So we get 2 to the 3rd over 1 to the 3rd. And we can write that out as 2 times 2 times 2 over 1 times 1 times 1. 2 times 2 is 4. 4 times 2 is 8. So we get 8 over 1, which equals 8. Letter F. We use the rule, power to a group you distribute to both the numerator and the denominator. So we get 2 to the -2nd over 5 to the -2nd. And I'm going to start by flipping this over the fraction bar this time, and I'm going to do it the slow way this time. When you flip it over the fraction bar, the base and the exponent should be flipped over together, and the sign of the exponent should change. So if it was originally negative, it should become positive. We're going to do the same thing with 2 to the -2nd, but first I'm going to just copy it down, and I'm going to show that when I get rid of 5 to the -2nd, I'm left with a hidden 1 down there, because really the 5 to the -1st is being multiplied by a factor of 2. Of 1, sorry. The 5 to the -2nd is being multiplied by a power of 1. So now in the second step, I'm going to take the 2 to the -2nd, and I'm going to move it to the denominator. So I'm left with 5 to the 2nd in the numerator, and then in the denominator I have 1 multiplied by 2 to the 2nd. The base and the exponent travel together. The sign of the exponent changes. So if it was a negative, now it's a positive. 1 times 2 to the 2nd is equal to 2 to the 2nd. And then let's simplify. 5 times 5 equals 25, and 2 times 2 equals 4. So we get 25/4. We could do the opposite. If we started with 5 squared over 2 squared, we could simply write this as 5 squared over 2 squared and change where this base and exponent are. We could flip it over the fraction bar, and when we flip it over the fraction bar, the sign of the exponent changes. Now let's flip the 5 to the 2nd over the fraction bar, and when you change its location, you change the sign of the exponent. So you flip it over the fraction bar. If it was positive originally, it becomes negative. So it's 2 to the negative second over to 5 to the negative second, which is what we had originally. So you can go either direction. When you flip, you change the sign. If it was originally positive, it becomes negative. If it was originally negative, then it becomes positive. Right, number 8, you can also do the same example using a variable. So in this case, we need a fraction bar, and normally we would write a 1 below it, just like if we had 5, we could write this as 5 over 1. We're going to flip this whole thing, the base and the exponent, over the fraction bar. And when you flip it over the fraction bar, the sign of the exponent changes. So if it was negative, it becomes positive. In the numerator, we're left with a hidden 1. Well, down here, if we multiply 1 times x to the third, we get x to the third. So our final answer is 1 over x to the third. When you get used to this, you're just going to recognize, all right, flip it over the fraction bar, and I'm left with a 1 in the numerator, and it's going to go a lot faster. But I want you to see the reasoning and the math behind it for now. Letter H. In this example, we start out with 1 over a to the fourth, and they'd like us to change it so that we have a to the negative fourth. We flip it over the fraction bar, and in the numerator we now have 1 times a to the negative fourth. In the denominator we have a hidden 1, because 1 is really being multiplied by a to the fourth. Just like if you had 1 over 5, you could say that this is really 1 over 5 times 1, because 5 times 1 is equal to 5. 1 times a to the negative fourth is a to the negative fourth. A to the negative fourth divided by 1 is just a to the negative fourth. And we could, again, go backwards and flip it over the fraction bar and get back to the original. So number 7H, the answer is a to the negative fourth. Now we're going to do a new rule, and this really isn't that new because we've looked at some examples, but we're going to talk about it and show you what the wrap is going to look like, the next part of the wrap. So the next part of the wrap is power of none, you get a 1. Power of none, that's like power of 0. If you have a power of 0, then the result is 1. So that's what that part of the wrap means. So power of none, you get a 1. Again, power of none, you get a 1. It doesn't matter what that base is. Power of none, you get a 1. Here's where it gets a little trickier. Power of none, you get a 1. Well, in this case, we got a negative 1. The reason is this. The 0 only goes to what it's directly beside. So the 0 only went to the 5, which means that the 5 is the only part that becomes a 1. The negative was not affected by that 0 because the 0 was only beside the 5. So the negative is hanging out here in front. The 5 to the 0th power becomes 1, and the result is negative 1. Over here, the 0 went to what it was directly beside, which is the set of parentheses. Inside the parentheses is the negative 5. So the 0 goes to the entire negative 5, which makes it equal to 1. It's a tricky one. Let's look at E. Again, the 0 goes to the entire set of parentheses, so the whole negative 200 becomes 1. Power of none, you get a 1. Works with variables too. When you have a complicated problem like this, instead of taking 0 to every single piece, just know that power of none, you get a 1, and you can be finished. Because what's going to happen is, if you take the power to every single piece, 5 to the 0th, x to the 0th, y to the 2nd to the 0th, z to the 3rd to the 0th, then you follow your rule, power to a power, you multiply. Power to a power, you multiply. What you're going to end up with is 5 to the 0th, which equals 1, x to the 0th, which equals 1, y to the 0th, which equals, guess, 7 to z to the 0th, which also equals 1. They all equal 1, so 1 times 1 times 1 equals 1. And so we had what we could have just had at the beginning if we would have recognized that anything even a large, long problem like this, if it's to the power of 0, it's going to give you a 1. Power of none, you get a 1. Now what we're going to do is we're going to work on the check your understanding. Let's see what you remember. So I would really like you to pause at this point, complete the check your understanding on your own, and then you can turn the video back on. All right, I hope you did that. We're going to go ahead and go over A. Y to the third multiplied by y to the sixth. In this case, the bases are the same, so you add the exponents. The base is the same and you're multiplying, so you add the exponents. So that's really y to the power of 3 plus 6, so we get y to the 9th power. Okay, this is part B of check your understanding. And here what we're going to do first is we're going to use the commutative property to reorder. So I'm going to multiply 5 by 2 first. Then I'm going to put the x's beside each other, x squared times x. And I cross out as I go so that I make sure I have copied down everything from the original problem. Y to the fourth times y to the third. Now I follow my rules. Here, I don't need a special rule. We already know how to multiply 5 times 2 and we get 10. Here we need a rule. Bases are the same, you add them up. 2 plus 1, this has a power of 1, gives you x to the third. And then over here, when the bases are the same, you add them up and we get y to the power of 4 plus 3, which is y to the 7th power. So you should have gotten 10, x to the third, y to the 7th. In C, when the bases are the same and you have a fraction, subtraction better be your action. So we take the numerator's exponent and we subtract the denominator's exponent. And we get a to the 2nd power. Letter D, power to a group you distribute to both the numerator and the denominator. So it's 5 to the 3rd over 3 to the 3rd, which equals 5 times 5 times 5 over 3 times 3 times 3, which is 125 over 27. PQ to the power of 3, power to a group you distribute. So it's p to the 3rd, q to the 3rd. Letter F, power to a group you distribute. Make sure you take it to every single piece, even the 7. So p to the 3rd to the 2nd power, q to the 2nd to the 2nd power. Now we get to use another rule. Power to a power you multiply. Power to a power you multiply. And then the 7 squared is really 7 times 7, which is 49. So we get 49, p to the 6th power, q to the 4th power. All right, letter G. Power to a power you multiply. Letter H. Negative exponents leave a scar, so you knock it over that fraction bar. So we get 2p to the 4th power. And down here we'd be left with the hidden 1, so if you want to show that you can, but if you have that in the denominator, it's really not necessary, so you can just write 2p to the 4th. Negative 5 squared, don't be fooled, the 2 only goes to what it's directly beside the 5. The negative sign is hanging out in front. So the base that it goes to, 5, is copied twice. So the negative symbol is not copied twice, so we get negative 25. Okay, in this case it's different. The 2 goes to the entire set of parentheses, which means the base is the entire negative 5, which means that we get 25. Okay, the 0 only goes to what it's directly beside, so a to the 0th power is equal to 1, and we get a result of 2. In this case, the 0 goes to the entire set of parentheses, so the entire thing, everything in here, 2a, that whole thing becomes 1. M, negative exponents leave a scar, so we're going to knock it over that fraction bar. In the numerator, we're left with a 4. The reason why we don't move the 4 with it is because the negative 2 only went to a. It didn't go to the 4. So you take the exponent and the base that it goes with. It only goes with the a. So in the denominator, we have a to the second power. Remember that when you flip it over the fraction bar, the sign of the exponent changes. It went from a -2 to a +2. 1 times a squared is just a squared, so it's 4 over a squared, and we are out of time.